Let's continue with more basic rules of differentiation. The next rule is quotient rule of differentiation. The quotient rule says that if y is a quotient where ux is the numerator and vx is the denominator, then to find dy dx, this will be the formula, and this formula will be given to you in the formula card. So let's try the quotient rule out. You're supposed to differentiate y equal 3x plus 1 over x squared minus 1. The first thing I need to do is to identify u and v. So I will let u be the numerator, 3x plus 1, and v will then be the denominator, x squared minus 1. Then I need to perform differentiation on u. I need to do du dx. So I need to differentiate 3x plus 1 with respect to x. The first term is 3x, that differentiates to 3. Second term is plus 1, being a constant, differentiates to 0. We shall do the same for v, dv dx. Differentiate x squared minus 1 with respect to x. First term is x squared, that differentiates to 2x. Second term is minus 1, since it's constant, differentiates to 0. Now we are ready to use the quotient rule here. So dy dx is equal to, follow the formula, v times du dx minus u times dv dx over v squared. Let's tidy up the terms. Open up brackets. Simplify. And this is my final answer. Let's try another example. Here you have another quotient, and I'm going to differentiate it, so I'm going to use quotient rule again. So I will let u be the numerator and v be the denominator. I differentiate u with respect to x. I differentiate 2x plus 3. With respect to x, I get 2. Differentiate v with respect to x. Differentiate x minus 4 gives me 1. I'm ready to do dy dx. Using the formula, it is v du dx minus u dv dx over v square. Again, now it's just simplifying. And tidying up the terms. This is my final answer for dy dx. Here is one other example. Let's try this. Again, differentiate with respect to x. So u will be numerator, v will be the denominator. Du dx, differentiating 2x squared minus 1 with respect to x, I get 4x. Differentiating x minus 1 square with respect to x, I get 2 x minus 1 power 1. And don't forget, I need to differentiate the function x minus 1 with respect to x. So that gives me 1. Now let's come back here, find dy dx. Again, applying quotient rule. V du dx minus u dv dx over v square. Simplifying. To simplify, in this case, I decided I shall not open up the brackets. Instead, I'm going to do factorization. This is because if I were to open up a square term and multiply 4x, it will get very messy. So I'm going to do factorization in the numerator instead. So identify first term versus second term here. What's the common factor? The common factor is 2. There's also common factor of x minus 1. And I think that's about it. Everything else I'm going to put inside this pair of square brackets. So looking at first term, because I take out 2, I'm left with another 2. I'm also left with an x. I'm also left with a x minus 1, power 1. Because I took out a power 1, I have another power 1. Second term, 2 is taken out, so no more 2. 2x squared minus 1 is still there though. And because x minus 1 is also taken out, no more x minus 1. So that's it. Close the bracket. Bottom, power 4. Now let's expand out everything within this bracket. Okay, I realize this can be cancelled with this to become power 3 at the bottom. At the same time, I'm going to simplify things here. So 2x squared minus 2x squared, no more 2x squared. This is my final answer. Here is another example. You're supposed to calculate the gradient of the curve, and the curve equation is given as this. And the point given is at x equal to 1. Now the idea of finding gradient is basically to find dy dx. So I'm going to find dy dx. I'm going to use this expression, this equation, and I'm going to find dy dx. So since it's a quotient, I'm going to use quotient rule. So I'll let u be the numerator and let v be the denominator. Now, square root, I'm going to convert to power half. Okay, ready to differentiate. Du dx, differentiating x plus 1 with respect to x is just 1. dv dx, differentiating 3x plus 1, holding power half, bring down power, powerless 1, so becomes minus half. And one extra bit, differentiate 3x plus 1. That gives me 3. Come back here, I'm looking for dy dx. Let's use quotient rule. v du dx minus u dv dx over v square. Now, let me just tidy up a little bit. Whatever I can tidy up. Now, since I'm given a point x equals to 1, I am going to substitute x equal to 1 straight away into dy dx. So substituting, pressing everything into the calculator just to get the answer. The gradient is minus 1 over 16. So this is the gradient at the point x equals to 1. Here is a little quiz. Answer is A. Because this is a quotient, if I want to find f prime x, I have to use quotient rule. So I let u be numerator, v be denominator. Differentiating x gives me 1. Differentiating 2 minus 3x with respect to x gives me minus 3. Coming back here, use quotient rule. V times du dx minus u times dv dx over v squared. Tidy up a little bit, and you get the answer, which is A.